Mr. Obiora is actually an IT consultant and automation master. He is also presently the senior information technology consultant for Conviva. Some of you may know, this organization, and he has, very vast knowledge when it comes to IT and at the same time, information technology consultancy. So today, he will be taking us on Python automation. He will, definitely it's going to be an hands-on session, and he's going to share us, his insight and the best way we can definitely use Python to achieve our goals as a DevOps engineer. So I want you all to please be attentive, try to note down points that will be discussed. This session is going to be recorded, or sorry, it's already been recorded. And at the same time, if you have questions, please try and note them down. And during the question and answer session, you can have the opportunity to ask your question. So, Mr. Obiora, are you there, sir? Hello?
Thank you so much, Jane.
Okay,
Thank you all for having me. Okay, so I'm going to share my screen.
Yes, please go on.
Can you all see my screen?
Yes, sir, we can see your screen.
Okay. All right, thank you so much. Like he said, my name is Obiora. I'm currently working with Conviva. Today, I'm going to take us through Python. Python is very vast, and I was made to understand that this is 1 hour, 30 minutes session. So we are going to go through fundamentals. I mean fundamentals. And when I say fundamentals, I mean fundamentals. So for those of us that are not technically inclined, don't worry, you follow along. And for those of us, I know we have different kinds of people here. Some of us may have known Python, and some of us don't know Python at all. We are all going to follow up with what we are going to do today. So first, I want to start to tell you that Python is not the big Python we have in the bush. It's quite different from it. So there is nothing to fear, nothing is going to bite us. The Python was actually invented in Netherlands in the early 90s, 1991 specifically, by Guido van Rossum. So it was named after Monty Python. Monty Python is actually a BBC television comedy that was done those days, and they decided to use the name, to name it, and they then write the program. And this Python was actually written by one person or initiated by one person, and after that, some developers and communities joined to start developing it and enhancing it. So it is open source. So you can easily go there, download it, and start using it, and use it to do anything you want without fear of anybody coming to request for license or for any payments. You can use it for various things. You can use it for scripting. Those of us working in AWS, you can use it to start doing your provisioning and everything, or reporting, anything you can think of, you can use Python to do that. And even if you don't know how to do it, you can Google it, and somebody must have done it in one way or the other and call it a module. We are coming to that, and you pull it, especially when you understand the fundamentals. So we want to go through the fundamentals now, so that with the fundamental, you can easily do anything and consult Google where you have any issue. It was used by Google from the beginning. When Google started, they were using Python, but now they have mixed it with so many other languages. I want to tell you that Python is becoming increasingly popular. Initially, Java was so popular, but Python now, you just open Python and start writing. You don't need to declare anything. You don't need to do anything. So, and so many people are going into it, writing all sorts of things that you usually do, all sorts of automations, and call it module, which you can easily pick and then incorporate it into whatever you are doing. So let's go. I believe if you have urgent questions, you can call me, ask the question. Otherwise, you can note it down, and we'll take all the questions at the end. So the first thing we need to understand is the installation and the documentation. I believe for those of us that want to be following, You can easily install it, and then whatever we say, you can try it immediately, and then note your question or ask the question immediately. So the first thing I need to explain here is, in programming language, we have what we call interpreter and the compiler. I want us to understand that fundamental first. Computer, as we all know, understands only zeros and one. Human beings is very, very difficult for you to be writing programs using those zeros and one. It will never be understandable. So what people did initially was to write a assembly language. An assembly language is like human readable form, but it's still very difficult. Then their assembly language will translate from whatever you are writing in that assembly language to the machine language, which is zeros and one. Now, that one is still very difficult for human to write without mistakes. So they now have high-level language. High-level language is of which Python is one of them. We'll take English like instructions, translate it to machine language, and the system will implement it accordingly. So for those high-level languages, it can either be interpreter or a compiler. Interpreter means read the first sentence, do what I said. Read the second sentence, do what I said. Read the third sentence, do what I said. So it's taking each sentence, implement before going to the next statement. Implement before going to the next statement. There is nothing like garbage or machine thing at all. But compiler, like Java, we first translate all the instructions from that language to the machine readable language before even executing a single statement. So Python is an interpreter and also a compiler, but it's mainly interpreter. So having understood what we mean by interpreter, so when we are writing the language, don't be surprised that the first language may execute successfully and you get error in the second language. It's because it interprets it, executes it before going to the next language. Had even is getting to the end, would have given you all the errors in that program, even before you run the single one. Then it will also interest us to know that all the Unix, Linux, and almost all operating systems, except Windows, have Python already installed. So even before you know, or even the operating systems you are using today, some of the programs there are already running Python. But the Pythons you see there mainly is Python 2 points, could be 2.x. And today we are in Python 3.x. So if you feel that what you want to do on that particular server, on that particular machine, is not responding to the instructions you are giving at that point in time, then you may need to install the current Python, which is Python 3. I think we are in Python 3.10 now. So the pre-installed versions may not be most recent, may be old one, but I assure you that it already have Python. If you want to know where the Python installed on that particular machine, you can just issue command, where is Python? And it will tell you the path where that server has the Python at that time. So for Python, you can download Python and install it using this URL. In the URL, you select the URL you
hello, please chat. Sorry, please. If anybody's on mute, please try and mute yourself, please. Okay, go on, sir. Thank you.
Okay. So when you go to this URL, you operating system where you want to install that Python and download for that operating system, and then follow the instruction there to install the Python. So the initial Python you install will have all the standard modules. I mean standard. There are other extra modules that individuals and communities have written in Python to make things simpler for the Python usage. And that is one of the reasons why Python is most simpler and most popular language today. In Python, you can just open your notepad, any text file or interactive or any IDE and start writing your program, and then go to wherever you install that Python and run it. So it does not need any special thing to start writing Python. I can open my notepad, I can open my VI editor, I can open my VM editor and start writing Python program. Even when you are using Windows, just open that notepad that you are so familiar with and start writing your program. The simplest program you can write there is print my name. You say Python program and you run it. You have written your first program. It's that simple. Today, in our hands-on, we are going to be using IDE. Although you can write your Python programs using Notepad, Notepad++, VM editor, or any text editor. But IDE is integrated development environment, has been enhanced. Part of the advantage there is that if you use anything wrongly, it will highlight it for you. If you run it and it does not run, it will tell you exactly where you are having that error. And you can easily go there and correct the error. So today, we are going to be using PyCharm for some of the practicals or hands-on that we are going to do. Then another thing is the documentation. When you are writing programs, you may like to read more about a particular program, about a particular syntax. First, let me explain I will come back to that. So for the documentation, Python documentation, you can follow, you can use this URL to access the documentation, and that can clear any doubts you have. Any questions so far?
I think you can
Oh, we are good.
continue.
We are good. We can
Maybe
continue.
at the end, then they can have questions to ask.
Okay. Just 1 minute, please. Okay. While running Python program, it can be interactive. You want to start writing, you want to see the result immediately. Or you can use IDE, write everything you want to write. So first, let's use interactive mode. Like we said, some of these things I will do it immediately before we move to another, and we'll be as fast as possible so that we'll be able to cover some things before the time runs out. So what I mean by interactive is this. Sorry, I'm trying to use this. I don't know why it's not coming up. Just give me 2 minutes. Can you see my terminal?
Not yet.
Not yet.
I thought I shared my screen entirely. You can see the terminal. It's a white terminal. Are you seeing this slide?
We can see the slide. Maybe you stop sharing and share again. Share your full screen. I guess maybe you only shared your slide.
Okay. Can you see it now?
Yeah, we can see it now.
Okay, maybe I should be running this slide in this mode. Okay. So the first thing is when you go to your, after installation of Python, once Python is installed, you can easily type Python on the command prompt, and it will take you to interactive session where you have this, where you can easily enter any Python command and you see the result immediately. So here I just want to add 3 plus 5 or 2 plus 5 and press enter to give you the result immediately. I can print and it will give you results immediately. So this is what I call interactive session. So at the initial time, when you want to try using Python, you can start from here. And then with time, you can go to Notepad or any other IDE of your choice. You can equally do this using PyCharm. This is PyCharm. So the IDE, one of them is PyCharm. There, it will give you a text editor where you can type whatever you want to type, any command you want to execute, and execute it immediately. So the same thing I did before, I can print and run it. If you go to run, you run the program, and it will give you a result immediately. So most times
you have to install the PyCharm separately.
Yes, PyCharm it doesn't come with the actual Python because you have other IDEs that you can use. So to me, PyCharm is almost the best from what I've seen from my judgment. But if you don't want PyCharm, you can equally do it in a notepad and then run it on the Python you installed. But I will encourage us to use PyCharm or any other IDE. Any other question?
Okay.
Okay. So the next one is, the next one is after writing that program, you need to give it a name, especially when you write it on a notepad or on IDE. We need to give it a name. That name is what we are going to use to run the Python at the end of the day. So, like the one I've just done, if I want to run it from the command prompt, you can run it from the command prompt. You can run it from Chrome tab. You can run it from anywhere. And that's the basis of the automation. Put all your instructions in a particular file, name it with extension py, and then make it executable on a Unix server or even a Mac, and then you can execute it anytime. You can schedule it to do a particular task at a particular time you want. You can do all sorts of things. So even when you are sleeping, when you are in traffic in Lagos, your system is working for you. So to run it on any Linux system, just type Python and then the name of the file where you store the Python program. But if it is also difficult, or probably you don't want to be running it that way, you can run it in such a way that once a Unix system or a Linux system sees it, it knows exactly where the Python is. Because sometimes when you type Python on the command prompt and the Python is not in your path, it will tell you that Python is not found, or the command is not found until you put it in that path. So in order to guide against that, you can put this in the program as the first line. Then anytime you want to run it After putting this, you put all your instructions and then change that particular file name to be executable. Add executable rights to it in a Unix machine. So in that case, you don't need to mention Python before running your program. You just run it as any other command in that Unix system or in that Linux system or even in the Mac system. So with this is what we are going to, I recommend this, which you can use for all kinds of automation or all kinds of your program. You don't need to mention Python. You just run the file and all instruction there will be executed depending on the parameter you pass to it. So let's move on to the basics. The first thing I want us to know now is that Python can be used for calculations. But before we talk much about calculation, let me introduce to you what we call variable. For those of us who may have been using calculator for a very long time to do our calculations, to do all sorts of things, and immediately after doing a particular calculation and you do another calculation, the previous calculation you did is gone unless you store it in memory. And in our calculator, you have only one memory there. So if you want to recall, you recall only the last one or whichever one you committed in memory. In Python program and in any other programming language, we understand that you can store anything and any number of things at any time. So we have made it in such a way that you should be able to store whatever you want to store and recall it at any point in time where you stored it. So in that case, when you are writing a program, the system will map out a small memory and you store that information there. It could be number, it could be alphabet, it could be alphanumeric, and you give that a name. That name you give to a particular area in memory where you store your thing is called a variable. And you represent a variable with a name. We're going to see the rules governing how you name those variables. But what I want you to pick at this time is that if you want to keep something for later use, you keep it a particular area in memory of that system and give a name to it. So in this case, in our example, we are going to do 34 minus 23. After doing this, we hope to use the result later in our program. We don't want it to disappear like that. We don't just want to see the result. So we keep it in memory and call that memory S. So this is how to do it. X is equals to 34 minus this. The result is stored in this memory. And anytime I want to access it, I'll access it with X. And also Y. Y is equals to 0. Anytime I want to access Y, I've already known what Y is. I can access it anytime. Or Z is equals to 3.45. All this, for each one we mention, it will go and create a memory automatically and store that value there. So now I can also take decision irrespective of what was in that memory, which I named Z. I will say Z is equal to, please let us note at this point, I'm still coming back to it. When we have double equal to, we are taking decision. So in computer programming, when you mention decision, the answer can either be yes or no. So you ask the question is yes or no answer. And in this case, I want to see if Z is equal to 3.45 or if Y is equals to 0. In also computer programming, when we mention or, anyone that is true, then everything will be true. But when we mention and, 2 of them or 3 of them or any number of conditions you give there must be true before you can say yes. So here we know that Z is equals to 3.45 or Y is equals to 0. If this condition is true, then this next statement will be executed. If it is not true, it will jump to the next statement and start from where the if statement ends. How do we know the block of modules to run if it is true? Is by indentation. Anytime you mention a statement and what is following is inside, there's a paragraph or indentation after that, then it means that wherever the indentation starts is a module till where it stops. So in this our case, we know that Z is 3.45, and we know that Y is hello based on the declaration we did up. That therefore, S will now be X plus 1. Sorry. What does it mean? In our memory, we have that X is 34 minus 23, which we can calculate as 11. So we know that in our memory, there's 11. So this statement is saying, go to memory, call X, and add 1 to whatever that is there, and store the new value in X. That's what this value means. So based on the previous one, what we have there in the memory of X memory is 11. Now this statement is, go to that memory, add 1 to it. So the new value of X now will be 12. That's what this statement is talking about. The second one is saying Y, go to the memory where we have Y and do whatever value you have there, add 1 to it. So at this point, we'll have a new concept also. This example is given in such a way that it will capture a lot of things, and that's why I'm trying to cover all of them for each particular one. In the numbers, when we say 1 plus 1, we know it is 2. When we say 2 plus 3, we know it's 5. And we use plus. Now, if it is alphabet, you cannot say H plus H and there is T. It's not possible. So in alphabet, when you use plus, it means concatenation. So anytime you are doing automation and you want to concatenate two words or concatenating or even concatenate number, you have to convert that number to string and use plus to concatenate the two. So what this is saying is Y, go to the Y, whatever you see there, add word to it. So when you print this, what you are going to see is hello world, because we know that previously we have hello there, and now we are having word. So let's see, we'll do a little practical, and then we'll move on. So
Hello, I have a question.
Okay.
Okay, from VS Code then. Is it possible to run Python directly from VS Code?
Yes, from VS Code, once you have your Python, this thing, you have installed Python, hold on. You can run it. On VS Code, go to the run. After writing your program and make sure that the program is working, you run it. There is run there and it will execute.
Okay.
VS Code is also good. It's
I actually have VS Code. I have VS Code here, so I'm trying to see how I can follow along with this class on this. As you're typing the command, I want to also be typing on VS Code.
Okay, VS Code is a generic, a kind of generic IDE. So you have to add Python module
Python extensions and Python
modules. Okay. Python extension.
Yeah, so you reinstall the Python and Python extension. Then with that you can run Python on VS Code. So any IDE generally can run Python. Yeah, it's just telling you that PyCharm is actually a very good preference based on experience and the fact that it's basically built for Python, if I'm very correct. Yeah.
Oh, okay. All right.
Yeah, thank you.
You can equally use your command prompts if you're on Windows.
On Windows.
Yeah, very correct.
That's after I tried it after installing Python. So I tried to call Python up. It came up, but I don't really like command prompt the way it looks. The way it looks, I don't really.
Okay. In order not to disturb the session, I'm going to share you a link on how to use Python on VS Code while we continue with the session.
If you install, if you install, I think when you install Python, it comes with that IDO environment. That IDO environment also has a notepad that you can also use. Once you click on that, on this idle environment, you click on file.
Okay.
It brings a notepad where you can write all your commands.
Okay, this
Then
I do stuff. Okay.
Yes, you save it as .py. You can run it if you want still.
All right. I've seen it. Thanks.
All right. Yeah.
Okay. So see what I'm saying. If you are using PyCharm, for example, or IDE, it can always tell you where you have error. Like what I'm doing now, it will give me red. And with this, it will point where the error is coming from. So you can easily go there, correct it, and then move on. So this error is, like I said before, indentation matters a lot in Python. Don't give unnecessary space because you are going to get error at the end of the day. The error is giving me now is saying that there is indentation here when I'm not supposed to give indentation. So be mindful of the spaces you are giving. White space after the beginning does not matter much, but white space at the beginning means a lot. In fact, it means the word to the whole word to Python. So I purposely put this space to explain this. When you go back now and run it, this error will no longer be there. Even so, but indentation is required at this point. If this condition is true, to execute some things and then continue wherever it stopped before, I have to give indentation to tell the line 4 that the next statement is what you are going to execute before moving to any other one that doesn't have indentation. So I'm going to give one line indentation. Okay, so I run this again. You can see it. It was giving us error, and good thing about IDE is it will point where the error is coming from. If you are using Notepad and you are getting error, you may be frustrated because you never know why that error is coming, and it will never point to you. You just see the error and that is the end. So we can see it's printing hello world. I can print X too. So when I say print Y, I'm saying go to the memory call Y and print whatever variable, whatever value you have there. And the second one, I'm saying go to the memory X and print whatever value you have there. You can actually run it from here without going to run every time. When you click on this, or even from this side, click on it and it will run your program, provided that you have executed it for the first time. So that is the power of Python and IDE. So we'll continue with the slide. So like I said before, indentation matters a lot, as we saw the error. If you give indentation where you are not supposed to give, you get error. And if it is under if statement or a loop, you give indentation when you don't mean to give indentation, it will execute it as indentation. And that's why we'll say It's cabbage in, cabbage out. So at this point, I want us to explain one concept. We have what we call error. We may have two types of errors. You may have a syntax error, and you may have a logical error. Syntax error means that your program will not run. You have the line is not correct. Python does not understand that language. We have logical error. Logical error means that your program will run. It will execute to the end, but it is not going to give you what you expected. It means that the logic is wrong. So when your logic is wrong, you get a logical error. Your answer will, it will give you answer, but it's wrong answer. When you have a syntax error, it will not run at all. The syntax, the language is not the rule of the language. So indentation can cause a syntax error. Indentation can cause a logical error. If I indent in the previous one, in the previous example, I want to calculate this and I want to do this too and store the value there without printing it. If I mistakenly put y here, thinking that I have done it in such a way that if z is equals to 3.45 and if y is equals to, or if y is equals to hello, then execute these two statements. But the second statement does not have indentation. It means that the if statement will only execute the first one. Whether that is correct or not, the second one will be executed. So let us always bear that in mind so that when we run our program and it's not giving us what is expected, it means that there is a logical error somewhere and you have to go through it again to take the logic you put there, especially the indentation. Do you put indentation where you are not supposed to put? And did you not put indentation where you are supposed to put? It's very important. So when you are putting space, especially at the beginning, be mindful of it. Space at the end or in between words does not matter. The first assignment to a variable creates the variable. In other programming languages, like Java, for example, before you use a variable, you must go to the memory, tell Java, create this memory for me. I'm going to use it later. Call the name Y. Python is different. Python, anytime you want to use it, it does not need to exist before you use it. Just go and use it. Immediately, the first time you are using it, it will create that memory for you and name it accordingly and store whichever value you use at that particular time. That's part of the reason why Python is popular and you don't need to be a guru before you use it. Python figures out the variable type on its own. If you declare a variable in Java, you must tell Java that this is a string, this is a float, this is an integer. But in Python, if I say y is equals to 5, Python will automatically know that this variable should be an integer. If I say a variable t is equals to Obiora, in quotes, Python automatically know that this is a string. If I say t or y or any variable name I want to give to it is equal to true, Python knows that this is a Boolean. It's a yes or no variable. So you don't need to declare it. That's one other advantage about Python. Then when you want to assign a value to that memory you declared and give a name, you use equal to. And when you want to compare two things to get yes or no answer, the equal to must be true. So let us take note of that. Don't say if y is equal to single equal to z, you get a syntax error. In that case, it has to be double. But if I say y is equals to t, I want to store the value of t in wherever memory I declared as y, then you have to use single equal to. I hope it's clear. Other operators that we can do on numbers, like we saw previously in our first example. Plus, you can easily use plus to add two numbers. You can equally use plus to do concatenation. Minus, you use minus to subtract from one number from the other. There's nothing like minus on strings. You can use multiplication. Star is used for multiplication to multiply two numbers. And we should bear in mind the mathematics we were taught during our school days. BODMAS. Python and other programming languages follow BODMAS. So if you want any particular calculation to be done first before any other calculation, you have to put it in brackets. Otherwise, at the end of the day, you have a logical error because the answer it will give to you may not be what you expected because of what is executed first before the other as stated in BODMAS. So it applies BODMAS too. Then we have division. You can use slash to divide numbers. This slash has many other things it does. But at this time, since we are talking about numbers, we use slash to divide number. I can say 10/5. So let me use command prompt to do some of these things. 5 divided by 3 will give me the answer, 2.0. I can say 5 multiplied by 67. It will give me 335 immediately. Then percentage is used to get remainder after division. If I divide 10 by 3, I'm going to get 3, the remainder 1. So our division will give me 3, which is the quotient, but percentage will give me the remainder, which is 1. So I'm going to do that. You get 1. So if you want to know if a number is divisible by a particular number in your automation, I'm citing example one of the use. You can divide that number with what you are expecting, and if you get remainder, it means that that number is not divisible. You can use it to take another decision or do some other things. So while running our logic, in sometimes when you are doing automation, I want to commit to the database. Each time I get 1,000 records, I commit to the database. Each time I get 1,000 records, I commit to the database. I can keep count of the records I'm having by dividing by 1,000. Anytime I divide by 1,000 and I don't have remainder, I will commit, meaning that the number of records has gotten to another multiple of 1,000. If I get remainder, I'll move to the next record. When I don't get remainder, I know it's 1,000 records, I commit. So you can use it to take decision in your automations. We have logical operators. I've talked about this briefly before. If I want to take decision, more than one decision, then I have to use and or not. I want to take decision whether the Linux I'm running is version so-so, and my program is so-so. Okay, if my variable is A is 5 and B is 10, and 2 of them must be true before I take the next decision or before I execute a set of programs, I use AND. So you use AND when you want all your decisions to be true before you take decision, or you use OR when if this is true, or if any of them is true, please do the remaining, do the what follows in the indentation. You use OR. When you have a particular thing, you want it at the end of the day, it's going to come true. But you want to execute, you want to take some decision or execute some statements. If it is not true, you use not. Just like in our SQL statements, where M is not in, that not means that if it is not, if it is there, don't do anything. But if it is not there, then execute programs. So everything depends on the logic and on what you are doing to determine when to use any of them. Now, we should be mindful of using and or on the same line. If you use and or on the same line, they are executed from left to right. So if you want a particular one to execute before considering the other one, like I have 3 statements that I'm considering. 2 of them must be true, or the third one must be true. And that means the 2 of them that I'm thinking must be true, I have to put it in brackets. So that and will be executed, remove the bracket before executing the or. Otherwise, you may get logical error because it will execute in order if you don't use bracket to give priority to the execution. Then the next one is the basic printing, to display something on the screen or any other medium which you want to direct it to. You use print statement. So we talked about data types initially, that in other programming languages like Java, you have to declare the data type. If I want to keep any number right from the beginning, I must tell Java that I'm hoping to keep string in a variable, in a memory. You declare that memory. But in Python, you don't do that. Immediately you assign a value to it, it will declare the particular type, the type of that memory. So we have integers. Integers are whole numbers. If you do any division that will result in fraction, is not going to keep that fractional part. It's going to, it's strictly for integer. So if you know that the calculation you are going to do, or there is a very tendency that whatever you are going to do has a fraction, please, right from the beginning, put a fraction to it. Although Python also is very flexible. I can declare initially, use x as an integer, and then later I assign another value to it as a float. A float is a number that has decimal. It will still take it. But you are going to get error when you declare a variable as a float and you are using it as if it is an integer. It will give you error. Like in my loop, or in where I'm taking decision, if I say from 1 to 5, it is expected there's nothing like fraction, counting fraction in Python. It's expected that the 2 is going to be an integer, and whatever I find in that memory, if it is a float, the system is going to, the program is going to crash with syntax error. So another thing we are going to talk about today is, we mentioned string. In our previous example, when I wanted to print my name, Obiora, I put the name in quotes. So in Python, anytime you want to talk about string, alphanumeric, that is not logical, then you have to put it in double quotes or in single quotes. Any of them. But a situation where you have the need to put a single quote in between it, you have to start with double quotes. I'm going to demonstrate this. If I say print, let me use single quotes, Obiora's computer. This is not going to run. It will give me error. Why is it giving me error when I have said that you can use single quote and double quote? The error here is because I started with single quote. So the next single quote it will see, it will assume that this is the closing quote. So by the time you put the third one, the system will get confused and give you error. So if I intend to use a single quote in between or a double quote in between, I just have to differentiate them. So since I want to use single quote in between, I have to encapsulate it with double quote. And that is it. So let us always know that when you start having that syntax error, know that the logic is, the rule of the program is violated. Then single quote or double quote is for a single line. If I want my statement or my variable to go through more than one line, you have to use either triple quote at the beginning and triple quote at the end, or use single quote, three single quotes at the beginning and 3 single quotes at the end. So in that case, it can go multiple lines. Like here, I can say that X is equals to until I close it, it will keep on taking something from me. So I can now print else. So from what I've done now, I have told Python to go to a particular memory allocated to me, call that memory S, and put this value for me there. So let me see what is that in S. So when I'm printing a variable, I don't need to put it in quote again. Just put the name of the variable. If you put it in quote, that variable will turn to a string and it will print it the way it is in that. So if I print it, whatever I type is what is there in the memory. So I can keep it in memory and be running my program and be using it to take decision depending on the kind of logic and the kind of automation I'm doing at that point in time. So other elements that we need to understand is white spaces. We have said that you should not use white spaces unnecessarily at the beginning. Any white space you use at the beginning, the system or the Python will assume that is indentation. So new lines to the end of the code, you can use white space, you can press enter and you go. Or you can use slash. You can see when I did my first example and I press enter, the system automatically puts slash at the end, thinking that I want to continue on the next line. So I had to remove it because I wanted my program to be on the next line. So each column, I'm going back to, this is what we call column, from top to bottom. If they are all in the same column, it means that they are the same line, they should be executed. But once it moves out from that column, it's in or out, it means a different thing altogether in Python. Like here in the previous example we had, I have this indented into inside, means that after if this is true, whatever that is inside after it should be executed. But if this is not true, I can change this to, if I change this to 8, I will now know that Z, what we have in Z is 3.48. Z is not equal to this, so this is going to be false. I'm going to run this program now, and we'll see the answer. We'll get 11, which is the original value. X 34 minus 23 is 11. This X plus 1 was not done because this was not true. And this is because this goes inside. If I take it outside to be the same line with this, and I run this program, it's going to give me 12 because it started the same line with if. So if whatever is true or not does not concern it because it's the same line. They are in a manager in our various offices. They are all the general managers. General manager cannot instruct anybody. So at that level, everybody is equal. But once you take it inside, it becomes a different thing altogether. So let us be mindful of it at any point in time. Comments. I can tell you that even if you write your program, your automation, 2 months, 3 months, or 6 months down the line, if you go back to that your program, you may get confused on what a particular line is doing. So in order to help you, or probably you are no longer there, and somebody else comes and need to change one or two things in that your program, the person may not understand the logic you put, especially when you used a compounded logic. So in order to put comments, you use hash. Comments is mainly used to understand the program. It's English like to describe what each line of your program is doing. So any point in time where you want to take a particular decision or a particular thing that you may come later and you may not remember what you had in mind for that particular logic, use comments. So here, I can use comments. Once you start anything with hash, Python is not going to stay to execute that line. It will jump it. So
Hello?
Hello.
Can you help us zoom out a little bit? Sorry. Down your terminal.
Okay, the terminal or the pie chart.
Yes, the PyCharm terminal.
We have zoom.
Check the under Windows.
Windows, there is Zoom. Yeah.
Okay.
Window, there is Zoom. Yeah.
It's not responding here. Maybe. Okay, let me try to reduce this.
Okay, don't worry. I've tried to. I think I have a function on my laptop. I use it, so I don't know whether it will affect that, but I can see now very well. Couldn't do it before. I can see it very well now.
Okay, so we can continue. Because
Yes.
it's not zooming, it's disabled here.
Stuff. Maybe you can
Control
try
Control
Command
plus.
plus. Command plus on
Eh?
your Command
Control
plus.
plus.
If it is disabled, means that you cannot use it at this point. See, it's grayed out. Is it better now?
Yeah, it's fine.
Okay. So, as we were saying, comment is very useful for readability, especially so that you come 6 months down the line, or for each particular variable you declared, you can write what you had in mind and what you are using it for, so that at any point in time you not get by the time your variable start growing like 20, 30, you get confused. And most times it's either you use comments or you can use a name that reflects what the variable is. You can actually use a name. It mustn't be just a letter. It could be a name. It could be Adaka Delta. I can use Adaka Delta. Any variable name, provided that it obeys the rule. We are going to see the rules governing naming variables. This is the same. So at any point in time, I know, okay, this calculation is because of the Adaka in Delta, and there won't be any confusion about it. Or you can use a comment. So that is the comment part. We'll move on. We have talked about assignments. You can also you can create by reference. There's something we call passing values by reference and passing values by parameter or by value. I don't want to go into it so much to avoid confusing some of us. But what it is basically when you are recalling whatever that is in the memory of what you have in the variable you declared, you can use a pointer and tell some part of your program to go to that memory itself, instead of retrieving it as a variable and giving it as a parameter. Go to that memory itself and do whatever you need to do there. Or you can take the value and present the value. So pointing them, using a pointer to point wherever that memory is passing value by reference. But picking the value and then passing it as a parameter is what we call passing by value. So the next thing is scope. When we are declaring a variable is just like a memory or a house. When you are inside that house and you declare a variable, that variable is local to that house. If you are inside a room and you declare a variable inside that room, I'm using an analogy so that we can understand it very well. If you are inside a room and you are doing something inside that particular room and you declare a variable in that room, if you leave that room, that variable will die. That variable is only in that room. If I have a building and I declare a variable when I am inside a room, when I leave that room and go to the next room, that variable is not visible to us. That memory that you named a variable is not visible to us. So I can use one variable name here in one room, use the same variable name in another room. Two of them will store two different values. And once you leave that room, that variable is dead. So in that case, we'll call it a local variable. So a local variable means it is within that area where you declare it. If you want that variable to be accessible anywhere in that building, you have to declare it as a global variable. You have to declare it outside all the rooms at the beginning, before you enter any loop, before you enter any function, before you enter anywhere, declare that variable. In that case, the variable will be available whether you are inside the room, whether you are under, whether you are in the roof. It is the same thing here in Python. So when you are declaring a variable, be mindful of the scope. That is what we are calling scope. Where can I see that variable? Is it available? Can I use it when I'm inside the room? Or I just want to do a temporary calculation, temporary things, and then move on and continue what I'm doing outside. In that case, you declare that variable as local. So let us be mindful of where we are declaring variable, and you go out and say, the variable I declared is, I can't see it here. It's because you declare it as local variable. Destroy any variable when not needed anymore. Like we have said, anytime you are declaring a variable, it's creating a memory somewhere and put your variable. What is the implication? If you have a 4 MB RAM and you are declaring a variable anyhow, it's taking that your 4 MB and storing value, and the remaining one will be available to you. At some point may not be enough to run that your program, and your program will crash. So don't declare variable because you want to declare variable. Declare variable because you need that variable, so that your memory will be preserved. Now, if after using that variable and you know that you don't need that variable again, please destroy that memory, destroy that variable, and reclaim that memory to be used to do some other things. So I believe we all understand what variable is. It's a particular area in memory where we'll store our value to be used later. Now, when you are naming that variable, there is a rule. You don't just wake up and start calling it whatever you like. One is case sensitive. Capital OBI is different from small OBI. Those are two different names. If I declare a variable with, okay, I'm going to show you this. If I say OBI is equals to Python, and I say OBI is equals to Java, these two are two different things. They have created two memories for me. I can print. Let's print two of them and see what it gives. First, capital OBI, Python. Then I'll print small letter OBI, Java. If I try to mix two of them, I start with capital and put small. Remember, I don't have any declaration like this. There is no memory here. So it means that I'm referencing non-existing memory. It's going to give me error because it has looked for that memory, you have not declared it. So here, before you use that memory, you must either declare it or assign value to it before you start using it. Otherwise, you get a syntax error. So the name can start with any alphabet. It can start with underscore, but it should not start with number. Don't start any variable with number. If you start any variable with number, you are going to get error. Python does not accept it. That's rule number one. Python is very strict. If you try to frustrate Python, Python will frustrate you. You discover that number you use as a variable, you may look for the error for the rest of the day, you will not see it just because of just one, to remove just one at the beginning of a variable. Now, another one is Python has some reserved words. You should not use that reserved words. If I have a variable and I call that variable print, Python will no longer be able to differentiate if you are talking about to print something for you or to take whatever you have in memory and display it. So you must not use the keywords. Anytime you use keyword, Python will always tell you that you can't use this. So apart from keywords, apart from not starting a variable with one, you can use any other thing to represent your variable. Or you can use a meaningful name, so that at any point in time, if you come back to that program, you can always remember what that variable is meant to store. Loop. I want to execute all the files. I'm doing automation that involves file, maybe my log files. I want to read all the files and look for a particular word or a particular pattern in the file. The first thing is to read all the files. Then for each of those files, I have to read the content of the file and look for whatever I want to look for. So in that case, you are going to put it in a loop. Loop means execute the same set of statements, the same set of statements on different items, on different objects. That is a loop. If I want to execute 500 lines and read the content of that file, then inside the loop, I will read a file, passing the file name as parameter, do whatever I want to do with that file, and then move to the next file, do the same thing, move to the next file, do the same thing. That thing you are moving to the next file, doing the same thing, move to the next file, is a loop. And while using loop, I want to sign one or give a word of caution. When you are using loop, there are sometimes if your logic is not true or is not correct, you may end up having indefinite loop. You'll be in that loop forever, and you'll be thinking that your system is hanging, whereas you have put that in a loop until you terminate it by yourself. So always make sure that there is a condition that will make that program to take you out of the loop. So example of a loop is processing 500 files. I want to do the same thing on 500 files. You don't expect me to start writing each file. I'll write a statement. At the end of the day, you have all the same statement repeated everywhere instead of executing the statement several times. Then we also have what we call nested loop, loop inside loop. Like this, the example I cited before, I want to pick all the files, read the content of the file, send it to Excel, create a graph, and they send it in a mail to my boss. So that file you are reading may be more than one file, maybe 1,000 files, and you are meant to complete this within the next 30 minutes or within the next 1 hour and publish the results. You have to put reading each of those files in a loop. Then inside the loop, you also have another loop inside the first loop that read the file. The second loop will read the content of each file. So I read the first file, I pass the name of the file to the second loop. The second loop will read the content of that file, send the content to Excel, and then exit the inner loop and go back to the outer loop. The outer loop will read the second file, pass it to the inner loop. The inner loop will read the content, do whatever it needs to do. So that is a nested loop. And the inner loop, the loop inside cannot intercept with the loop outside. The loop inside must be completed. You must make sure that whatever that is happening inside must be completed before it comes to the outer wall. If you don't close the inner loop and try to close the outer loop, you get error. You can use a local variable. The variable you declare inside the inner loop is not available. You cannot see it in the outer loop. It's local to that inner loop. So if you want to do anything or change the value within your inner loop, you have to declare it outside that inner loop. So it will be available to both the outer loop and the inner loop. So you can pass the result of, like I've explained, you can pass the result of the outer loop to the inner loop, and you can pass the result of the inner loop to the outer loop, depending on how you declare your variable. If you don't store it, you must store it in a variable. Don't expect to do 3 plus 5 inside the inner loop without storing it anywhere. You will never see it outside that. In fact, after executing a program, a particular statement, and you don't keep the result in a memory, in a variable, the next statement, that particular, you will not be able to see the calculation you did previously. So we are going to take there are so many loops, but we are going to take maybe 2 examples of a loop. The first one is for loop. For is just like our English language. I want to execute a particular statement from 1 to 10, from 1 to 50, or I want to execute 1,000 files. You know where you are going to start and you know where you are going to end. So in that case, you can use for loop. But if you don't know the beginning and you don't know the end, then for loop cannot help you. So for loop basically is used to execute a program or instruction a predefined number of times. It can be 10 times, you know it's 10 times. If you don't know, if you want to execute a files in a particular directory, then, and you don't know the number of files, of course, most times we don't know the number of files that are generated. The first thing you need to do before you go into the loop is to write a statement that will count the number of files. After getting the number of files, you now go into the loop using that count, which you stored in memory, to execute your loop. So in all, before you use loop, you must know the beginning and you must know the end. We can also, we talked about nested loop. You can also have nested for loop. In that case, the outer loop may be different from the inner loop. Any questions? Okay. So like we said before, the inner loop, the loop inside must be completed before the outer loop. And you remember we said that when you use for loop for 1 to 5, the next statement you want to execute under that loop must be indented. If you put it the same line as that for, it is assumed that they are in the same category and it will not be executed. So let us remember that first one. Anytime we are using anything at all, not just loop or not just any statement that is dependent on the first statement, that dependency must be there using indentation. Then the second one is while loop. Why something is true, please continue. This is mainly where we always have issue, because we say why. If I want to run a statement, for example, that will never end. I'm writing a web service. I've written a web service using my Python, or I have written a web service, let's say a web service, for example. And once you run that program, you want that program to remain. Like we see previously in our examples. Once you run a program and at the end of the program, it will exit with status code 0 or status code any other thing when you get error. But if you want it to continue to remain there, you can put that in a while loop. It means that it will be running. So you can write a web service. You can publish a SOAP service and put that SOAP service in a while loop. It means that it will run forever. As long as nobody stops it, it will be running and anybody can call that service and get whatever it wants. But a situation where you don't have intention of making it to run forever, you want it to exit at some point in time, and you don't have any condition that will make it to exit, it will give you, it will be running forever and you'll be thinking that your system is hanging. It's not hanging, it's running and it's running forever. based on the instruction you gave to it. So what I'm saying here is when you are using while loop, you need to be very careful. While loop, as long as whatever you are doing is true, it will repeat itself. As long as it's true, it will repeat itself. So you must have something within that loop, inside that loop, that will signal the end of that loop. So in that case, it will exit. So here, we're going to use this as an example. I said that I declare a variable, I, to be equal to 1. Then I will say why I is less than 6, execute all these statements. But if I is equals to 3, break. Break means exit that loop, go out of that loop. I don't want again. But if I is equals to 4, continue, means don't do anything, just go to the next value. And you can see here, at the end of the loop, before I go back to the loop, I will add 1. You can add 1 to I. You can do it this way, or you can do I is equals to I plus 1. So initially I is 1. Now it will do all this, come back to this, increment it, I is now 2. It will come here and check, oh, I is still less than 6. It will start doing this again. Make it 3. Come back to this, oh, I is still less than 6. It will execute it again. Come here. At some point, I will become 6. It will come here, oh, I is not less than 6. I is in fact equal to 6. It will not do any of these things. It will exit the loop. If I don't put this statement here in the while loop, this statement will execute forever, because y will be 1 forever. There's nothing that tells y that y should change to 2, 3, 4, or any other value. So y will remain 1 forever, because that's what is in the memory. So why I'm emphasizing this is you can have a logical error if you are not taking note of all this. Your program will run, but it will not give you the result you wanted. The next one is if then else statement. I have decision I want to take. There are 2 decisions. I'm comparing 2 things. If this, do this. Else, do something else. That is what we call if then statement. If A is equals to 1, then do so. I can decide not to use else. I continue. So what it means is, okay, let's do practical on this so we can understand it better.
I change the values.
Hello, can you please mute yourself?
Okay, this is a simple program. Like we said, it's not like Java that you start declaring doing this. I just assign A is equals to 1, B is equals to 5. I'll take the decision. If A is greater than B, use column. Column means do all the following indented statements. So you use column every time that you want to execute a number of things, and then what follows will be indented. If you are using Python, merely you put column and put enter, it will automatically indent it for you and the next statement you are typing without giving space will be indented. So here, what I'm saying is, if A is greater than B, print AY. Then whether it is greater than B or it is not greater than B, it doesn't concern me. C is equals to A times B and print C. So at any point in time, whether the statement is true or not, the next statement will be executed. So it depends on the logic I have in mind. So as we can see from manual execution of this program, A is not greater than B. So there's no way we are going to expect this print statement to run. So I'm going to run this because you have to pass through your line, the code again and see what is expected. I'm getting 5. And that means this was not executed. Print A plus B was not executed. It just went straight to C equals to A times C, which is A times B, which is 1 times 5. And that will give me the result as 5 with exit code of 0. If A is greater than B, print this. But if A is not greater than this, print this. If A greater than this, print this. But don't do C is equals to A times B. But if A is not, do C equals to A times C. So I'm going to do this. Here, I'm going to see C is equals to A plus B. So I'm introducing else this time. Else. This program will run, but unlike before, if this is true, the first one will run, the second one will not run. But if it is false, this first one will not run, the second one will run. So when you have 2 alternatives, it's either I do this or I do this, and not 2 of them. You use if then else statement. So I'm going to run this program. I'm getting 5. Now, let me try to make A to be greater than 5 and see what happens. I'll make A to be 8 and run the program again. So in that case, 13, the second one did not execute because the first one is true. Now, if I have more than 1 condition, I need to use else if. If this is true, do this, else. If this is true, do this, else. So in that case, I have more than 2 conditions. I have like 4 conditions, and they are mutually exclusive. Then you use several if statements to do that. So I can say if A is equals to B. See the essence of PyCharm. Like we said before, single equal to is for assignment. But if you want to take this condition, if you want to take decision, it's going to be double. So if you make that mistake and you are using PyCharm, PyCharm will highlight it immediately for you. Using ordinary text editors will not do that. Although VS Code will also highlight it to you if you have that Python extension. So in this case, it's not going to be else. I'm going to use elif. Normally, it's supposed to be else if, but Python has compressed it and give it a 1 word and call it elif. So anytime you are seeing elif, it means else if A is greater than B. Then do C is equal to A times this. Else. Finally, that is the final else. I'll say C is equal to A minus B. So let's print C. You can see print C stands in the same line with every other one, meaning that print C is not in that loop. So I'm going to run this program with the initial declaration we have. I'm getting 40. What's supposed to give me 40? 40 is when I multiply. It means here, this is what was executed. It means that A is greater than B. Let me make A to be less. I'm going to call it 3 and execute it again. It's going to give me -2. What executed? Minus. So A is not equal to B. A is not greater than this. So means that it boils down to the last one, which is else. What if I make them equal? I'm going to get 10, meaning that the first one is executed. I'm adding the 2 together. So what we are saying in essence is that when you are comparing 2 things, if statement is your best bet. Now, friends, we are going to function. Maybe I should be a little bit faster this time because of time. Function. In a particular program, if we need to do a particular thing every time, I'm going to use offices, for example, so that we can understand it very well. Anything concerning finance, money, recruiting people, IT work, even within IT, we have various functions. So function is specialty. Help desk, their function is to receive call, attend to that call, and escalate where necessary. And the finance is everything about money. They know it, and others. So function in Python follow the same rule. If I want a particular thing to be done, I will just program it as a module and keep it somewhere and call it a function. Anytime anybody needs that kind of functionality, it will just call that function, execute it without repeating that statement again. Just execute it, give the person all the values, all the parameters needed to do that, and then it will execute it and return result to you. Can either return result or to just do whatever you want, and there's no need for result to be returned. So that is a function. So I'll give you an example of a function quickly. To start a function, to define a function, you need to use DEF, means define, then you name the name of that function. I can name it addition. And inside that addition, I'm going to add 2 variables, S and Y. Remember I said this definition is going to do a number of things. So in that case, I have to put column after the name definition. I will say that C is equals to X plus Y. Then return. If I want to do anything, I will complete it there. I'm not going to return anything. But if I want to return a value to whoever that requested for that message, probably you ask me to check files and check if there is any error written in any of those files. Tell me the line, tell me the particular server IP address and the line and the name of that particular file. Then it means that your automation has to return something to you. It will go through it for each of those files. It will look for that keyword you specified there. If it is found, it's going to return it to you. If it is not found, probably it will return to you, nothing was found. So in that case, it's going to return to you. But a situation where you have a function, a function that goes into your server and then delete old servers, is not meant to return anything to you. It has done what you asked it to do, which is to delete any server. In that case, return statement is not required. But in our case, I need to return C. I can have other ones. So I've defined this. If I run this program now, nothing will happen because I'm not calling it from anywhere. I just created departments, and I have not called the department to do anything for me. You can see nothing was returned. So I just created departments in our various offices. One department is addition. I'm using department because that's what we all know, but actually in programming world is called a function. I have created a function, two functions. One is to add numbers for me. The second one is to multiply numbers for me. I have not asked them to do anything. So if I execute this program, nothing happens. I have to call it. To call a function, you just mention the name of the function, addition. Then you put values that is supposed to add for you. The first value I'm putting there will correspond to the value X. The second value will correspond to the value Y. Unless if you decide to alter the order, then you need to put the variable name, and that is by reference. So if I execute it now, I will get results. I'm going to print this to show me on the screen. You can see I just called a function. All the logic, everything concerning addition is already entered. Everything, all the logic concerning that department, concerning whatever I want to do, concerning reading a file and sending a mail, concerning everything is already in that function. I only need to pass the IP address to identify the particular server. It will go to that server, do whatever that is programmed in that function, and get back to me. So I can decide to change this from 40 to 700. I don't need to know whatever it does. Just give me my answer using your logic, and it will give me my answer. The next one is multiply. Multiply will just multiply the two values. Whatever logic he wants to do, I don't care. So in this case, sometimes you can have a colleague that knows Python very well. You can tell the colleague, please, this is the logic I want. Or if even Google, you can go to Google for a particular thing you want to do and copy whatever function they put there, put it in your program and call it up, and it will do what you want to do, and you move on. No skimping. So this one now, if I execute it, it will give me 420. Whoever that write that function knows the logic, knows whatever it does. If it has problem, I'll call up that person to go and do it. Or you can do it yourself to avoid repeating the same line of code every time using different parameters. So that is a function. We'll move on. Now we'll come to class. Class is a blueprint for creating an object. Class will have a lot of things in the class. I'm going to use analogy because class confuses a lot of people. I'm going to use analogy to describe this class. And I'm going to use building, which we all see every day. Or even in our various offices, I believe most of us are in IT. We have, before you start executing, you draw, you design. You design how the network is supposed to be before even start building that network. In also building, you draw your architectural building. You put where window supposed to do, the size of the window, the actions the window supposed to do, that it should be pushed out or it will be a sliding window, and all kinds of things. And the parameters that you're going to put in that building, the color of the building, the number of stories of the building, the number of floors, and everything concerning that building. You have drawn everything, make all the corrections, and it's available. The same thing, the same analogy can be used in class, irrespective of whether it is Python or any other programming language. A class is where you define what a particular architectural drawing is going to do. That is going to drive, is going to have gear. The gear should behave this way and behave that way. Everything concerning that is defined in a class. And you use function, all the functionalities, you use function to define the functionalities in that class. And so anytime you want to do anything to build a house or to create a class, you call up that class, you instantiate that class. Instantiating a class means, in our analogy, architectural drawing, take that architectural drawing and build a house using that drawing. We all know that in architectural drawing, you can use it to build 1 house, 2 house, 3 house, 500 houses, but it cannot be the same house. You cannot name it the same thing. It can be on the same land, but not exactly in the same foundation. So in a class, once you try to create an object, so that house you build is an object, it's an instant of that class. You give it a name, and that name is what you are going to use to refer to the functionalities of that class. So in a building, I build a house in number 1. I use the same architectural drawing and build number 2, and even build somewhere in Ghana with the same drawing. So the one I build in Ghana, I can call it 1 Ghana. The one I build in Nigeria, I can call it anything. You must use name. Then I can say Ghana.glass, and I'm referring to the class, the house built in Ghana, and I'm referring to the glass inside it. So those classes, there are a lot of things here, but I just want to introduce you to a class. Now, when you build an object.
Hello, Mr. Obiora.
Yes.
Please, can you try to round up in 10 minutes?
Okay, no issues.
Thank you.
Okay, we'll be faster now. Okay, when you build a class, the process of building that class is called instantiation. You say you have instantiated a class, and whatever you are using that is an object. You give it a name. Let's say for a school, for example, I build a class for students. Then when I instantiate it, I'll call it class 1 dot name of the person, Obiora dot first name, Obiora dot last name. It means that class, the student class, has been instantiated and called Obiora. So that is a class. And when you instantiate a class, there are default things that happens before you even issue another instruction. And everything that you want to happen before you issue another instruction, you have to put it in its function. So once this class is instantiated, whatever that is in init will be executed. Moving on, we have exception handling. Like we have seen so far, if there's any error in our program will crash. And when you are running a program, there are different users in that particular program. And the user may not necessarily know the parameter you have in mind to pass the correct parameter. So the person may pass wrong parameter and your program will give error. Just imagine that you are running a program, or you are using a CRM application and it's giving error here and there. You dump it and go for another one. So in order to handle that and tell the person that the value you entered is wrong, we have what we call exception handling. So the first thing is you try to print something. If that value does not exist, that you have not declared it before, it will tell you that something is wrong. But if everything is okay, it will execute. So to handle exception, you use try, exception, and finally. So try will try to do something. If there's any error there, if there's nothing, it will execute and move to finally. But if there is any error there, instead of crashing your program, it will go to except and do whatever you put there. Now, finally, whether it run successfully or there was error, finally will stay run. So most times, finally is where you deallocate memory to avoid using up memory, your system memory, when it is in fact not supposed to be used. So finally, you zero all the memories by setting all the variables you use to equal to 0, especially objects created from class, because those ones will take bigger amount of memory. You set them to null. So just before we go, we'll have modules. Like we started, Python is very popular. Part of the reason why it is popular is that some of these functions that we have done, or some of the common tasks that we are doing every day, some lovers of Python has taken it and write extensive program on it. It's just for you to go to the internet, download it into your program, incorporate it, and use it. So they call it, for each of those ones, they bundled it together and call it a module. You have a module that sends mail. You don't need to start writing mails. one by one to send mail. Just go to mail module, copy the mail module and put the parameters, the username, password, and the IP address of your mail server. Boom, a mail is sent. We also have, we have more than 100 modules, but I'm going to tell you popular ones why we end. We have pandas. Pandas is mainly used for calculations, anything numeric, number, and all the rest. With Python, you can read CSV file. You can write to CSV file. You can read CSV file. You can read Excel file. You can pass parameters to Excel file. You can read a CSV file and transfer the content to Excel file. You can equally then copy take the Excel file and send it in a mail. You can read a text file. You can do pilots, pivoting in pandas, and anything you can think of that you usually do in Excel. You can use pandas to do that. You can write your output back to CSV file and then read the CSV file and send it as a mail in your automation. We have also sys. Sys is mainly used there. It has so many functions there, but it's mainly used to redirect input. Maybe whatever input, whatever return your function have for you, you can decide to redirect it into a file and then send that file to you. Maybe there is an error. You want to use Python to monitor your program, your servers. And if there's any error, you should send that error to you as a mail. So in that case, whatever output that is returned, you have to write it in a file and attach that file in a mail and send to you. Of course, we are using your phone. You can always get that and know that you need to log in and check what is wrong. Then we have OS. OS is a module you can use to access the OS of the particular system you are using to run that program. You can use it to change directory, do all kinds of things using this OS module. Datetime is used to manipulate dates and the time. Paramiko, this is mainly used in a case where you are doing automation for your servers. So you can use this to access any number of remote servers using the IPs and their login. Check, execute commands, check whatever you need to execute, or check as if you SSH into it as human being. So whatever results that it has, it can return it to you. If it is part of what you needed, you can send it to yourself in a mail in case of an automation. So this is mainly used. You can download it and then use it for whatever. We have SCP. I want to copy file from the remote server into my local server, or from my local server into any number of servers. Or I have 1,000 servers. I want to copy the log file to a particular destination and then close, move to the next server. You can put those servers in a loop and use SCP to copy those files. We also have other modules. Shuttle is used to move file. I want to move file from my disk in the remote server or whatever server from one directory to another. Zip file is mainly used when you download your log files. If it is large and that it cannot be sent in a mail, you can use zip file, compress it, and then attach the zip file to your mail and send. We also have matplotlib. You use it to plot graph. Probably the report you are going to send to your boss every 7 o'clock every day. Supposed to have graph of whatever information you have in that Excel. You use matplotlib to plot that graph. Okay, thank you so much. Maybe we can entertain questions if we still have time. Thanks.
Yeah, thank you so much for the wonderful session. It's quite intensive and also basic and very comprehensive. Thank you. Now we will be taking questions and answers. Is there any question from anyone? Please, you are free to ask your question now. And at the same time, I would also like to confirm, Obiora, do you have assignments or tasks for the mentees to work on over the week, or you will definitely send that to us after the session?
No, I will send it after the session, but I will send it after the session.
Okay, okay, thank you so much.
Before the end of the day, not necessarily immediately.
Okay, no problem, no problem, no problem. So now we will entertain question and answers. Any question from anyone, please?
Okay, I have a question. You know, if you are an admin that manages several systems that spans across different operating systems, like different Windows OS versions. I manage some machines that run on Windows 10 and Windows 7. And if I want to carry out tasks, I normally use Windows command prompts. I run my automations in CMD, like I use a bash file to run it. So if I want to move, probably try to use Python. Is it possible to carry that automation, or Python has some environment where it can run, or I need to get Python installed on the other end in the remote system before it can run?
Okay, thank you so much. Python must be in the particular system you are running that program, because it is the one interpreting the program and then taking the instruction. So you only need to run it where you schedule that program. You don't need to run it everywhere. The other one is the operating system command. So one of the reasons why Python is popular is that the same program that you run in Windows, you can just copy it and run exactly the same program in other operating system without any, or let me not say without any change, with just little change. And that little change is mainly when you are trying to move to a path. Let me say, for example, I'm going to give you an example of the little difference there. Whatever task you do on Windows, when you are referring to the path, in Windows, you know that the path, we use backslash to identify the path, but in the Linux, we use front path. So in that case, if you write a program that will run on Windows and you have identified the path that it will look for the file as this, this is going to give you error. Can you see my screen, please? This is going to give you error because backslash in Python means escape sequence. So when it sees it, it will think that it's an escape sequence and it will not run. So in this case, you have to make it double. And if you run the same program on Linux, this is not going to run because there is nothing like C. Apart from these minor differences, every other command, every other standard thing runs without any change in Windows or in Python. Just write it, execute it in that command prompt. Boom, it's okay.
I don't think my question has been addressed very well. Let's say I have a command that I'm running using a bash file. You know, if I run that command, it's going to cause CMD from my system. And when I send it to a remote system, probably I want to remote certain systems. I want to remote to them or restart them remotely. Now I will run a command using command prompt to use PSExec, like a remote process, to restart those systems, like PCs or whatever. Now that kind of, we have such command also in Python that we can run remotely, from our system to affect those remote PCs, or do we need to install Python on the other hand for it to work? Or is it that the Python on your system will communicate with the CMD on with the shell on the remote systems for you to be able, or let me put it in a summary.
I understand what you are saying. I think
I understand what you are saying, and what you are basically talking about is, take for example, let's say you want to probably restart a server, or log out of a server, and you want to use Python modules to do this. First of all, you need to understand that before you can run a Python module, your your endpoint must definitely have, before you can run any Python script, your endpoint must also have Python installed, because that is what we interpret, which is what Obiora is saying. And at the same time, we have different modules that you can use. Take, for example, we was talking about OS. You can use like a OS system module, which is Python to probably like, shut down system, restart system, log out of the system. You get me? So these are just examples of what you can do. But one thing is that your target OS, or your target server must have Python installed, because it's actually what's going to use to interpret what you are about to run.
Exactly.
I think I need to put it, let me put it differently.
Okay.
Let me use an analogy. What's the name of the person I asked question? Sorry. What's the name again? Okay, Lawrence. If I'm Igbo person and I need to communicate to a Yoruba person, hopefully you are Yoruba, and I can only speak English, and the other person can only speak English, I cannot communicate Yoruba, but I cannot communicate with Igbo to the person. That person does not need to have English, don't know English or learn anything. It's you that I'm giving instruction to communicate to that person that's supposed to know in Igbo, know English, and know Yoruba. So what I'm saying in essence is where your instruction is running, supposed to have Python. Any other system is communicating to does not need to have Python. It will communicate to those systems using the basic that operating system commands.
Yes.
So if I log in, we don't have time, I would have shown you one. I'll run a program from my local laptop and it will go to my VM Linux system and do a command. I don't need to have Python in that remote server. What I will run in that remote server is normal shell command, but executed remotely from my Python program.
Because the reason why I'm asking is because I had this when we did the PowerShell class. I tried to turn one of my scripts into PowerShell script, and I tried to run it. Most of these systems I'm running these script on are Windows 7 systems, so they were not taking it. So I had to get to know that you need PowerShell has to be on the other end for that script to work. So I think I understand it fine. It's okay. I'm okay now.
So in this example, there must be a module that does this thing you just mentioned. I'm going to search if there is one, and I will send it to the coordinators. Probably they can send it to you. You study it in details, and probably you can carry out what you need.
Okay, it's fine. Thank you.
Thank you so much for the clarification. Mr. Obiora, any other question? Another question? I think.
Okay, I have a quick follow. I don't know that there's still time for it.
Yes, please go on with your question, please.
Okay, thank you so much, Mr. Obiora. Mine is just like, from your experience, can you just give us best practices of writing a production-based Python code that can be able to give optimum performance, good memory utilization, and all those stuff? Because there's something you say when you're making reference to using a count to check what you're trying to return. For instance, you said, well, for loop, you can use a count to pick out what you want to return instead of just saying for what is what. You count through the array or the list before you now return whatever you want to return inside it. So I just want to know, is that not like using majority of your memory to do that particular operation instead of just performing the return from that particular array?
No, when you do a count, it can be 1 million. 1 million, if I write 1 million now, is 7 letters. 7 letters will not take your memory. You are not storing the files. If you are taking the files and storing it in memory, the size of the files will count. But I'm counting 1, 2, 3, 4, 5, 6, and I count 1 million. That 1 million is like storing any other 5-digit number. In fact, Adaka Delta may be more than 7 digits. So in that case, it occupies more memory than the 1 million I'm talking about. So when you have 1 million, you are reading the files. You read this file, you process it, drop the file, and read the next file. You are not keeping that file in memory. You are keeping only one file at any point in time. So it does not affect the memory.
Okay, thank you. Can you just this part of the question, like best practice of writing a good production-based Python code from your experience?
From my experience, if you are writing a Linux, of course, most of us are using Linux. Our servers are all running on Linux. First, you need to declare the particular batch program inside your program, inside the script which you are running. Then use function. You must use function extensively. Don't try to repeat your code. Otherwise, if you are not there, or even you, 6 months down the line, may not understand what that code is talking about. Don't keep much of things in memory. If you need to use a large chunk of things later, don't keep it in memory. Don't keep it in a variable. Store it in a file and remove that variable. When you need it again, read that file and do whatever you want to do. And at the end of your program, maybe you have a clone job. At the end of each script, always try to zero down all your memories. Set all the variables you use, especially if you are using class, set them to null so that whatever you have inside there will be deleted. So those are the best practices I can remember for now.
Okay, thank you so much.
Any other question?
Yes, sir. Please, just a request or clarification, not really a question. Thank you, Mr. Obiora. You mentioned you were going to send the module which Lawrence asked of. I just want to request that just beyond that one, if there is a URL or something, location where we can find a list of other modules that we can go to. Please help us share.
Okay, I'm going to send in a chat here. Those people, their mode of explanation, I think, is okay. And you can search for so many modules. What they call them? I think Geek for Geek. Okay. You can check this. I think they have a lot of explanation and a lot of module. You can easily pick module. If you don't know how to use it, they will give you an example of it, and you can move on from there.
Okay. What do you call it? Geek for Geek?
Yes.
Okay.
Okay, thank you so much. I think that answers the question. And you can be shared for what's it called, Geek for Gig. You can also check what's it called, official Python documentation. They have what they call their module index, where you can also see lots of module index for different versions of Python, like Python 3.9, 3.7, 3.8, 3.10. You can also see there. And there was a particular book that you also saw, which is also, I think, when Mr. Obiora was sharing his screen. It's a very good book also, and it's kind of what kind of practice base is called, what is it called? Automate the boring stuff with Python. It's a very good book, and you can always use those books to learn more about Python, and also how to what's it called? How to automate some stuff or some little tasks with Python. So these materials will definitely be shared on our Discord page. And in the absence of no questions, I want to make some announcements. And first of all, next week, Friday, same time, 8 p.m., we'll be having our presentation. And the presentation is definitely going to be on the assignment that, that will be shared with us after the session. And, if possible, if Mr. Obiora is around, you can also, review your performance on the assignment and how you've implemented it. Another information is that next week, because, we have been running from, I think, end of July, and next week, Saturday, is Independence Day, and at the same time, we want to use that opportunity to actually just go on a break while we resume back on the 8th of October. And when we are resuming back, then we are going into some other core DevOps. We've tried as much as possible to give you a very good fundamentals and some things to actually lay your your structure or your blocks to lay them on. So by the time we are coming back from our break, we are going to go more advanced. We are going to go more we're going to be more intensive in also in the teaching approach. I think these are just the little information I have for you at the moment. I don't know, Oluwaseun, do you have anything you want to share there?
No, I'm fine. We're okay.
Okay. Thank you so much. Thank you, Mr. Obiora. We are pleased to have you here. Thank you. We really appreciate your time, and we will definitely be waiting to hear from you as regards the assignment. Thank you, everyone. Thank you for being available. Take care and have a wonderful weekend. Bye for now.